Applications of forces, dynamics and inclined planes. Example 2. So we have a block with mass 2 kilograms and weight 2g. It's accelerating up the incline. Friction is opposing this motion, and this is basically F equals mu r, where 0.3 is the coefficient of friction. Now, to calculate the acceleration, we first work out r, and then from r we can work out the frictional force, and then we can resolve forces parallel to the incline, use F equals ma, and then we'll get the acceleration. So we're going to resolve forces parallel and perpendicular to the incline. So this force here, the 2g force, has this perpendicular component to the incline and this parallel component, and this force here of 25 newtons has this parallel component and this perpendicular component. So now looking at forces perpendicular to the incline first, taking this as the positive direction. Okay, so in this direction we have this force, we have this one, 2g cos 10, and we have this one. The directions are the key things here. Look at the direction of the arrow for each force. Anything in this direction is positive. So that one's positive, negative, negative. So we have r, then we have a minus 25 sine 10 from this one, minus 2g cos 10 from this one, equals 0. The resultant force perpendicular to the incline is 0, and then we can work out the value of r, 23.643 newtons. Now resolving forces parallel to the incline, this is the positive direction, so we have this force, this one, and this one for friction. Anything in this direction is positive, so positive, negative, negative. These three are the only forces which are parallel to the incline in this direction. So F equals ma, so we know we have a resultant force because there is acceleration in this direction. So we have 25 cos 10 minus 2g sine 10 minus, now this will be the maximum frictional value, which is 0.3 times r, F equals mu r. So that becomes 0.3 times r. We already know what r is equal to, we've worked it out. And if we simplify, substituting the value of r into our calculation, and then solve the equation to get 7.06 meters per second squared, that's the magnitude of the acceleration. Acceleration is a vector. Its direction is given by this arrow here on the diagram. For further practice, try these questions.